Hello everyone, today I'm gonna start a Coroutines series. What is Coroutines and why do we need Coroutines instead of threads? Why do we need it? First, we should know about the basic concepts. First, you should know about program. What is program? It is simply a task to which we assign some instruction, and it processes that whole instruction in a thread. It processes that task, and it takes some space in the memory of a mobile. So there are some other things like process the actual instance of your program. To the program, the instance of your program is process. This process is just the instance of your program which you execute, and there are some other things like process ID, state, and memory handles of networking file system. Means it gets some memory in your mobile, have some state. You will know about all these in upcoming videos. This program is just a thread of execution. Alright, it would go on this sequential execution here. It processes these all instructions one by one. It processes these all. First it would process this one, and then this one, and so on, and number of instruction, how much we would give it instruction, so it would process that. There are 4 lines like this. First it would print this first one line, and until it finish, and when it get finished, it would execute this second line, and then third one, and then fourth one at the last. It would execute these all one by one. It cannot jump from this line direct to this fourth one. It cannot jump. It would go through one by one. Alright, now what if this one task gets some more space and get some more time here, like if we assign one instruction and second one gets some time, so what we would do with it? We would creating a separate thread for it, because if this one is not executing, so how the third one would go get executed. So so for that we would create a second thread for this instruction 2. Alright, like this. If we would create another thread here, and this one would execute one by one, and this one would go alone and process at the last. It would come directly to this. When it get finished, it would get to this thread, main thread. Alright, now what types of instruction are we executing these days? Like in this one, if you look at this one, what are these processes which takes that much time? Why it takes why it is different from these other ones? Why it is different? Because this is maybe input output operation, like we are executing some task here, like it is getting API, etc. Tasks go one by one like this. Alright, now what if this API, like here, if this executing in one thread, and this one is waiting for a response from API, so the third one can't execute. So for this one we would create a second thread here, and after it completes, it would get directly, like for these processes it get that much time, like reading file from system, so it would get time, and these can be executed. So for that we would create another thread here. Now can we reuse the thread when it is waiting for some reasons, response or input output operation like question? Can we use it? So here, look at this. First it would go on this, and here are some thread pools, like if this is executing one by one, and these both get some, it is a long-term task. So for that we would call to this. This is a thread pool in which all threads exist. So for that we would call this thread pool, say that we need a thread for executing one of our tasks like this one, and after that when it get alone here, then we would again send a message when this one completes that we need another thread, because we have another long term task. So for that we need another thread, so they would give us another thread here. Alright, what are coroutines? Why do we need it? Like here it executed inside a thread. We have talked about all these threads. This video is about coroutines. So why we talk about threads? Because thread is important to know, right? And these all coroutines exist in the thread here. It is in the same thread order. Okay, one thread can have multiple coroutines. The threads are a little bigger, so it can and every mobile has a limited memory. It is some limit. It can't get more and more threads and create threads here. So one thread can have multiple coroutines, so for that we use coroutines here, and it is a little cheap. And one thread we can use multiple coroutines, like if one thread can use multiple coroutines, so another thread can also use. So that's why we can use multiple tasks at one time here. It gets a little memory. If you look at this coroutines name here, it's first co means cooperative. It is cooperating with one another, and the second routines, which is just a function, the functions which are cooperating with each other. So that's called coroutines here. These all coroutines, these all functions is cooperating with each other. And now here again, if you take a look at this, if this is executing, and here it get a long term task, so it gets create another coroutine here, another coroutine for this, and it gets started from this start here. And when it get finished, so it directly send this same coroutine here, and directly start from there. And here when again the long term task comes, so here again we get him alone and create it for that, create coroutines or thread for that one. So I think you understand how does these coroutines work, and in upcoming videos we would do it using Android Studio, and you would get it programmatically. Alright, in this video I was just giving you an idea how does it work and why we need it instead of threads. If you got the idea that what is coroutines and why do we need it, and for what you have come here, if you got that, so please hit the like button and also subscribe to our channel and press the bell icon. Thank you.